Welcome to Pomodoro Joe for Saturday, March 4th, 2023. Today we're looking at LeetCode problem 2444. Count subarrays with fixed bounds. We got a hard one today. You are given an integer array nums and two integers, min k and max k. A fixed bound subarray of nums is a subarray that satisfies the following conditions. The minimum value of the subarray is equal to min k, and the maximum value in the subarray is equal to max k. Return the number of fixed bound subarrays. A subarray is a contiguous part of an array. All right, we'll put 25 minutes on the Pomodoro timer and get started. So of course, the first thing I'll do is have some result, set it to 0 to begin with, and we will return the result at the end. So I think for the very first pass, we'll just approach this the simplest way possible. We'll go through every single subarray in our nums, see if they satisfy the condition of min k, max k, keep a count, and return the result. All right, so let's do that. Okay, so here I have my basic framework. We're going to start at every single possible starting point in the range of length nums, and then we'll go from every starting point to every possible ending point in range length nums. And then we will check every single number in that range from start to end plus 1, because we need this to include the endpoint as well. And what do we do when we go through these numbers? Well, we're looking for a min and a max value. So let's just have some min and max out here. And we'll start the min num at infinity, because we'll be essentially just looking for anything lower than our current minimum. So we need to start it as high as possible. Same thing with our max num. We want to set it as low as possible, so we're looking for anything that's higher than our current max num. So we'll just go from every number in the range from start to end, looking for a new min or max. Then we just check. If our min num and max num match the min k and max k, then this subarray does meet our criteria. All right, I think that should do it. Let's give that a shot. Okay, so this works. We'll submit it, but I have my doubts about it passing. All right. So we don't fail because of a wrong answer, but we do fail because the time limit is exceeded. We only passed 24 out of 51 of the test cases. So this probably isn't going to work. So my doubts about this one came because we have 3 levels of embedded loops, which is usually a bad sign. I also know that we'll be basically going through the same ranges of numbers over and over and over again. So that's also a bad sign when we're recalculating the same ranges. So let's toss this out and see if we can find a better solution. So what are we really looking for? We're looking for all the subarrays that contain a min k and a max k, but do not contain anything lower than min k or higher than max k. So we could start at the start of our nums, keeping track of where we find min k's and max k's. And anytime we find a number that's lower than min k or higher than max k, we basically have to close out that sub-range and start over from the new start point. All right, so let's just go through our array one time, keeping track of our starting point, any mins and maxes, and then we'll reset our starting point and min and max anytime we run across a number that doesn't fall within our accepted range. In this case, we'll just enumerate our nums so we have the index and the number. Makes it easier to grab the values we're looking for. All right, so if our number is less than our minimum or greater than our maximum, then we basically have to start over. It means that this number cannot be part of our accepted subarray. So what's starting over mean? Well, we'll have some start index, and we'll have to reset that. So out here, we'll keep some start index. So this is basically saying this is the start of our current subarray that may or may not contain min k, max k. Let's see, I think we'll also want to store either a Boolean, have we found our min k, or we'll keep track of the index. That might be easier. So let's do that. So min index. All right, so we're going to keep track of our starting index for the current subarray that we're looking at. And then we'll keep track of where have we seen the min k and the max k within this starting index to our current index. All right, so if we ever run outside, if we get a number that's lower than our min or greater than our max, we're going to have to reset our start. And we'll have to reset our min and max, that's true. So min index equals none. And then we can just continue. All right, now if we get to this point in our loop, it means that our number is between min k and max k inclusive. So we can set, if we don't have a start, then we can say this could be the start of a new subarray. All right, now what about our min and max? Well, let's see, if this number is our min, then we'll want to keep track of that in our min index. And same thing with the max. Okay, so now we're keeping track of our start index, our min index, and our max index. If we have a min index and we have a max index and a start index, well, I guess we'd have to have a start index if we're in this, this part of the loop. But if we have a min index and a max index, then this could potentially, or actually is, a possible subarray. So let's see. Now I'm checking against none here specifically instead of just saying if not min index, or if min index, because min index could be 0. That's totally a valid index to be. So I'm specifically checking against none. So if the min index is not none and the max index is not none, that means that our subarray starting at start and going to our current I is a valid subarray. So we could, it's tempting I think to say, okay, result plus equals 1. Kind of works, but not really. So what happens here? Let's see if I can draw a diagram. This might not work out so well. My apologies in advance. So at this point, I tried to draw out some diagrams to describe this part of the problem. Unfortunately, I just wasn't able to do it with text, and I don't have any good diagramming software. Essentially, you can think of this part as having 3 components. The core component in the middle has the min and max values contained. Then you have everything to the left and everything to the right. Now you need to essentially count all the elements to the left and multiply that by the number of elements on the right. All right, I'm having a really hard time describing how this works. I'll see if I can think of a good way to describe this and come back to it, but we are running low on time, so I'll just see if I can wrap this up. So we basically need to find all of the elements between our start index and where the left side ends, which is going to be essentially where our min or max index starts. Then we also need to add 1, just because you always have at least one array. So let's say that we have 0 elements. Our start is the min index, for example. And we have a min and max index because we've checked both min and max are valid. If we just have a min and max index with a 2-element array, that still counts. So if our start index is 0 and our left side end index is also 0, we still need to add at least 1. All right, let's try this. All right, I'm going to submit this and see how we do. All right, we pass. We actually do pretty well with this one. So we beat 91.15% for runtime and 69.18% for memory. Okay. We could probably do some cleanup in here. Gain a little bit on runtime and memory, but I'm running low on time. I'm still trying to figure out how to describe this without... One of these days, I'll get some way to diagram and I can draw this out for you. For now, I hope this can kind of make sense. I made one last attempt to diagram this out. It kind of failed, sorry. All right, folks, I'm gonna leave it here. I am out of time, but that's your solution for today. I apologize for not being able to describe this one very well. I'll see if I can come up with a better idea to how to describe this. If I can, I will let you know. I will post a new video, but if not, I encourage you to try this one on your own. All right, hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and write better code than I do.